pressure patterns. Okay, so pressure patterns. So quickly 2-3 points. First point is that the pressure pattern is not zonal everywhere. Okay, what is the meaning of the word zonal? They are continuous latitudinal belts. Okay, and why is the pressure pattern not zonal? Single reason kya hai? Okay, because of land water difference. The properties of the land surface is different from the properties of the water surface. Water can maintain its temperature for a long time, and land can become hot, can become cold. Okay, it can fluctuate in terms of seasonality. That is why this belt, which should have been high pressure sinking air, agar bahut garam ho gaya, the air will start rising. This belt, which should have been low pressure rising air, agar bahut thanda ho gaya, the air will sink. And bahut thanda, bahut garam, very cold, very hot, ye land mein hi possible hai. Okay, that is why this belt, which should have been a high pressure belt or a low pressure belt, is now getting disrupted because of the seasonal heating or cooling of the land. So the pressure pattern is not zonal. Why not zonal? Because of the land water difference, the surface properties difference. Okay, land has a different property, water alag hai. That's one. The third point here is the surfaces which are relatively more homogeneous, which are relatively more uniform, wahan par almost zonal hai. So what are the latitudes of zonal? We have the polar latitudes are zonal. The subpolar of the southern hemisphere, this is zonal. Okay, and I said even the equatorial can be considered as zonal. If you look at equatorial region, land wala part, do chota part hai. One is, so imagine, okay, this is okay, South America like this, and this is Africa. Yahi par land hai. Africa mein bas itna land. This is the land for equatorial regions. And for South America, this is the land for equatorial regions. Uske baad, ocean here, ocean here. Pacific Ocean is massive. Okay, we have got oceans in the Indian Ocean. Yahan pa a couple of islands hai. If you look at the entire stretch of the equator, okay, bulk of the land is or area is actually water, and jo bhi land hai, it is continuous heating. Okay, so because of which the equatorial can be considered as a belt. There is some disruption, but that's not of much consequence, not much significance. So I understand why we have a belt at the poles. We understand why we have a belt at the subpolar low in the southern hemisphere. Equator ka ye kahani hai. Continuous heating for a long time throughout the year, and the land parts are much less. That's why for all practical purpose, we may consider the pressure pattern as a continuous zonal belt. Uske baad basta hai aapke paas 3 belts. One is the subpolar of the north, subtropical of the north, and subtropical of the south. Water will have the permanent property. The subpolar low, water mein rahega. Subtropical high, water mein rahega. Subtropical high is on the water. Water will not change temperature much. Land is where things will start changing. So in this latitude, Canadian high winters, Siberian high winters. In this latitude, Colorado low in the summers, Sahara low in the summers, Tibetan low in the summers. And in this latitude, the only significant one is the Australian low pressure. Bas, that's all. Okay, ye aapko janna tha. So in the subpolar low belt of the north, there are 2 seasonal cells. What are they? The Canadian high and the Siberian high. ये कब होता है? ये winters में है. Cold air is heavy air will sink. In the summers, it will disappear. Colorado low pressure, because Colorado is a land area, no? Okay. The subtropical areas never become cold enough to develop a high pressure. In the summers, they will disappear. Subtropical areas hai. Like equator is here. This is the Tropic of Cancer, Tropic of Capricorn. Whatever land we have around this is very, very hot. This is where the sun is shining directly for considerable length of time. Whatever land we have in Africa can get very, very hot. Okay. And Tibetan plateau elevations mein hai, it can receive lot of sunlight, okay, without much of losses. This is one of our understanding problems. Dekho, as I rise up the height, it becomes cold or it becomes warm. Becomes cold. Okay? As I rise up the height, it becomes cold. Cold what? Cold on an average. But what happens is, in elevations, the atmosphere is very rarefied. Yahan par zyada atmosphere hai nahi. Not much of clouds are here. Not much of droplets are here. Okay, less of air. And the elevation is in the tropical area, subtropical area. The sun shining is very, very strong. Very, very strong, the land can become very hot. Yes, the moment the sun starts sinking, the land can become very cold again. So on average, okay, elevations are cold. But the time for which the sun is shining, it can be very, very hot. Okay, that's why, you know, these mountaineers put on goggles, right? The sun glare is very powerful. Some of you have been to hill stations in Shimla also. Summer daytime is piercing hot. आप खड़े नहीं हो सकते वहां पर इतने आराम से. But yes, the moment it becomes afternoon, the temperature will fall rapidly. So the problem is the assumption is a Tibet plateau तो इतने elevation में ठंडा होना चाहिए. Yes, on average cold है. On an average, it will have snowfall also. But for those few summer months, for the few moments where sun is shining strongly, Tibet can become very, very hot. हमारा imagination क्या? Tibet बोलते ही दिमाग में क्या आता है? White snow everywhere. Yaks are moving maybe. I mean, one Tibetan monk is also probably walking. Imagination है ना? Tibet का क्या imagination है? It's an area with lot of cold conditions and you have got snowfall. But ऐसा नहीं है. Summers, if you look down on Tibet, it's actually green. You'll have small, small patches of lakes. You'll have grazing economy there. There is sheep, there are cattle. Yak is a very important livestock. Yes. Okay. So Tibet is not frozen entirely. हाँ, cold है. But ऐसा नहीं कि Tibet में सिर्फ बर्फ ही होता है. Typically what we see in Shimla also. ऐसा थोड़ी है Shimla has snowfall throughout the year. Summers can be terrible in terms of heat. Piercing heat. ठीक है? So that's what we have to remember. So Tibet, because of elevations, और elevation कहाँ पर है? It is in the subtropical belts. The same Tibet, अगर और north होता, then probably it would have been very, very cold. But subtropical area, strong insolation, Tibet can become very, very hot. Yes, absolutely. In these kind of conditions, skin problems बहुत होते हैं. Because the glare is high, strong insolation, your skin can burn very rapidly. You're right. ठीक है? Equator zone, yes, so those are the small modifications. The overall temperature belts will shift north and south. That's right. That's not wrong. That's right. Yes, Tibetan low pressure is good for the monsoons also, correct. Australian high, छोड़ दो टारगेट. Australia में हम high की बात नहीं करते हैं. It should have been Australian low pressure. Yes, but in the southern summers का मतलब है north में winter चल रहा है. That could be a problem, Dagar. Australia will have low pressure in Australian summers. मतलब ये month of January होगा. Okay, ऐसा नहीं बोलो कि इस winter होना चाहिए, नहीं. Okay, it is summers, it is hot, but in the northern winters. So month of January, Feb में होगा. In the month of July, Jan, Australia will become relatively a bit more cooler. ठीक है? So remember that is a low pressure. Forget about the high pressure there. Remember, Australia has a low pressure in the summers. Okay, so you understand this now? So in the low pressure areas, the Canadian high and the Siberian high. Then I said in the subtropical north, ये seasonal था. In the subtropical northern belt में, we have again seasonality. Summers में क्या क्या होगा? Summers will have the Colorado low pressure. we'll have the Sahara low pressure and we will have the Tibet low pressure. Okay, whereas subtropical areas of the south जो है almost insignificant है South America में, almost non-existent in Africa. Whatever we have is in Australia. Okay, Australian okay, low pressure in the summers. और यहाँ पर summers remember is in the month of Jan and Feb. Southern summers की बात कर रहे हैं. These are the seasonal or the temporary cells of the pressure, and the rest are all the permanent ones. Aleutian low pressure is permanent. Icelandic low pressure is permanent. Azores high is permanent. Hawaiian high is permanent. We have a high at the Pacific Ocean subtropical, high at Atlantic Ocean subtropical, and high at the Mascarenes Basin, a Mascarenes high in the Indian Ocean. ठीक है? और ये चीजें, remember one thing, try to have a pictorial memory. आपको आंख बंद करके दिखना चाहिए. Okay, Aleutian low, Canadian high, Icelandic low, Siberian high, and again Aleutian low pressure. You should be able to see it when you close your eyes. You have the Hawaiian high pressure, Colorado low pressure, Azores high pressure, the Tibetan Sahara okay, low pressure, Tibetan, and then you have again the Pacific Ocean. Yes. ठीक है? This is the pressure patterns on the surface. Now, a very important discussion I initiated yesterday was the pressure pattern in the upper troposphere बहुत अलग है. Upper troposphere is not related to surface conditions directly because atmosphere is heated from below. So, whatever variations you can have is in the lower atmosphere. Upper atmosphere में बहुत अलग कहानी है. The vertical cells of Hadley and Ferrell, okay, they do not reach up to the tropopause. They are much, much shallow. In the upper part, there is one single pressure gradient. देखो, at the surface level, we have, okay, the following gradients: subtropical high pressure, equatorial low pressure. So this is one gradient for the winds. We have the subpolar low pressure. This is one more gradient for the winds. We have the polar high pressure. From here also one more. So there are three main gradients. Always the winds will move from high towards low, from high towards low, from high towards low. But what happens is, in the upper troposphere, okay, these don't impact all the locations here. इसका impact ये है कि this develops a relative high pressure compared to this one here. This is relative low pressure. Okay, the question was, sir, why does this air not reach till here? उतना energy नहीं है, as simple as that. If I throw a stone, जितना energy है उतना तक जाएगा ना. The energy that we have here because of heating is not good enough to take the air here. But this pushing can always push this air above. It is possible here. Okay, so this pushing can push the air above. So this air kind of becomes more tightly packed. More tight packed means it has high pressure. No, or don't say, यहाँ पर cell भी नहीं है. यहाँ पर the wind is moving like this. There is no cell as such here. ये cell है. This is a cell. This is a cell. There is no cell here. This is the direction of the pressure gradient force from equatorial high pressure in the upper troposphere above equator towards the polar low pressure in the polar latitudes in the upper troposphere. This was one additional point we added, that the pressure patterns aloft are very different from what we see on the surface.